Welcome to Voices of Video. As part of our preparation for NAB, we are speaking with partners across the VPU ecosystem about the architectural realities behind modern video system, not product features, but the design decisions that shape how platforms actually operate. For today's conversation, designing video system around latency budgets, we are joined by Stefan Ideler, co-founder of i3D.net. Stefan has more than 20 years of experience in infrastructure, networking, and game services. From the early days of consumer-hosted game servers to today's globally distributed orchestrations platform powering always online environments, he's been deeply involved in how real-time systems scale across regions. Stefan, welcome. Great to have you with us.
Thank you, Anita. Very glad to be here again at the Voices of Video.
Joining us as a moderator is Leonardo Nito, Director of Market Development for EMEA at Netint, who moderates these conversations from a market perspective, bringing forward recurring patterns, concerns, and architectural tensions he hears from video teams navigating real deployment decisions. Leo, I'll hand it over to you.
Thanks, Anita. And yeah, it's great to start doing this for the European market and therefore the European context of what we do as video technologists. And Stefan, thank you for joining us. How have you been?
Very good, actually. Of course, now with the new year, there's also a little bit of a pause in the travel season within our main industry niches, which is starting to pick up again this and next month, where the famous industry conferences in the games industry start place, which is, of course, one of our big operating theaters, and, of course, also the broadcasting conferences, such as NAB in Vegas.
Yeah. Which brings us to, the themes that we want to discuss, and I think our audience is curious about, and, just to, tackle it directly, we're hearing repeatedly that, latency is not just a performance metric, but rather becoming a structural constraint. Teams, even people on the commercial side are not just asking how fast is the encoder or where do we find bottlenecks. I think the task itself has gone quite complex as the demand of video increases constantly, and of course monetizing it becomes much more challenging. I think they're asking, where should compute live? What happens to density and thereby quality and other parameters, when you start affecting those variables. What does this do to failure domains? And, fundamentally, that shifts the architecture discussions away from centralized efficiency towards more placement and locality. And obviously, i3D is a great example of the outfit that you guys manage worldwide. Yeah. So, Stefan, at what point do you think that latency becomes the dominant constraint in systems design?
Actually, it is a good question. There's a few different ways where it comes into play, right? One example is, of course, it depends on what kind of workload are you trying to serve. Going back to our game route, computer games is a workload. Streaming, it could be like a sport match going on. It could be just a simple movie that you're streaming. For example, in the case of gaming or the sport match, latency is definitely a constraint. The higher the latency, the more delays, the more buffering you have to do to account for variances in your streams. And you really don't want to hear your neighbors already cheering when on your screen the goal has not been even made yet. So for certain workloads, latencies matters a lot more compared to some others. Another big question is, of course, where are your users? And from which point in the world are you serving your content, your streams, your infrastructure, and so on? Also, there, of course, what is acceptable in terms of your latency budgets. But what also people sometimes tend to forget, even if your latency budget might be relatively relaxed, there are questions like, okay, is it a good idea to serve all of your worldwide users from, for example, 2 locations in the world, like one in the US, one in the EU? What if something goes wrong there? Then we are thinking about blast radius. Wouldn't it be easier to run multiple sites closer to the user? So if there are disruptions, the internet breaks all the time, continuously, you can work around it by going around it. So summary, depends on the workload. It depends on where are your users and what are their specific demands. And sometimes you also have to look at the specific region where the connections by default might not go as the bird would fly. They might take large detours, so you need to be a little bit more, you need to research a little bit more on where the users and what's the geographic makeup in terms of the fiber connectivity, in terms of the latency, because there might be things that you might not expect. And the third part is, of course, it's a very age-old discussion, of course, the centralized approach versus more distributed.
Yeah, correct.
And if the stream especially is important, like has real-time needs to current events or anything, you definitely want to avoid or minimize the risk of a total outage. And I also believe, because there are disruptions in the internet, you might have, for example, quality constraints in one region with a certain ISP, but due to your measurements and operational excellence, you see that in your 5 other locations, for example, in Europe, that throughput constraints are not there. Then you have the freedom, if you control from where the user gets their stream, to optimize the quality by shifting some of that load towards your other locations. Instead, if you had only one location, if something is not performing on the other ISP's end, then you're kind of stuck and you cannot act right away to alleviate any operational problems.
And I think by the nature of what you have shared just now, one size doesn't fit all. And I think that, right, when you're trying to tackle these things both from a technical approach, obviously, but then mix it with commercial realities, it's rather challenging to find, let's say, a relatively, I don't want to say the word holistic, but a rather, let's say, encompassing way that can make sense for both technical challenges and also commercial objectives. Within that respect, what do you think? Latency stops being, let's say, a tuning exercise, or maybe one desire of or customer objective, and rather a driving force in changing infrastructure ever. But obviously, we're mentioning things doing it closer to the customer.
Yes.
Sometimes we're doing it closer. But at some point, sometimes it's difficult to pinpoint where do we start asking ourselves, wow, we have to stop thinking maybe on simple systems that find themselves either or, and then where would you say or give an opinion, or where that point is where we have to think maybe, wow, the infrastructure or something much larger has to change?
Yeah, I think one thing that resonates with me, that if you want, in my opinion, if you want to do it well and do it well over a longer time, so not just a lucky shot, one off and yay, it went well. And actually, there's a lot of skill sets you need to combine to properly understand and design around the low latency requirements and what that means for your infrastructure deployment. I mean, if you would look at a very simple thing, back in the days, low latency, you build up a big location, you do some connectivity with the ISPs, you do some handshake agreements, and then you would have it in place. But in today's world, with today's massive traffic volumes shifting around, that's no longer good enough. You need to monitor this. There's a lot of operational things that are come into play. There is, as we spoke about before, ideally you start distributing the environments, but there's of course overhead when dealing with distributed environments. And depending on the requirements of your product and the latency requirements and the guarantees that you need to meet, that overhead might be acceptable. but there's always a tipping point. At one point, does it become a burden versus does it become a gain? There's it's a tricky question. It's not as simple anymore. It's just okay. I have a sports stream. It's X latency. Maybe if you do it once or twice, but if you want to build a long-term product with customer satisfaction, returning clients, then you really need to start looking at the whole, almost actually a holistic view of all the different little things that you can turn on to optimize the experience. I think that's what teams underestimate. Like you can fire up some streams in the cloud or get a single server and with a 2 or 25 gig uplink and do your first things, but scaling that to a more professional level, a lot of complexities get into play where you, at first glance, you might not realize that they are there. And that's kind of the difficulty. Yeah.
What do you think teams, often underestimate, these requirements? It seems obviously something that, from an initial approach that you would take it rather as a big priority, but why do you think that is?
Well, one thing that's definitely a common that could be a common pitfall. Yes, you have latency, right? And latency from a certain test location might be low, but the second question you should always then ask is, what's the throughput that I can sustain? So if you know where your audience is, you will know what their main ISPs are. So you should be asking questions to your vendor. What's the capacity from you towards these ISPs? The latency might be good right now, but if you're already running at 90% capacity, part of my online content in the evening, it's not going to be good. The latency will probably degrade, there will be packet loss, the throughput will not be there. Normally when you do latency tests, you run a script, you look at the numbers, but you need to move beyond this and also test the throughput or find providers to give you real-time insight into, for example, that throughput towards these end user ISPs. The other big thing that people forget is, yes, operation overhead, I mentioned before. I've met with companies where they realized they had to distribute towards multiple locations because they had very strict latency requirements or some problematic legislations and so on. But then, before they knew it, they were working with like 40 different vendors at 40 different locations with 40 different support teams, 40 different anti-DDoS systems, 40 different billing systems. That required full-time effort just to manage that as well. Of course. And yes, of course, you can then reduce the overhead by trying to consolidate vendors and everything, but it's something that when you start, you might not realize. Of course, you can also, depending on how cost-driven you are with your platform, you can also just pick a single cloud, of course, and expand everywhere there. But we see with many companies nowadays, especially with egress-heavy products like content distribution and streaming, that cloud might not always be the best fit cost-wise because of the egress costs associated with running such a product. So by default, you're almost looking at, again, physical vendors around the world who can give you that best deal on, of course, all the egress bandwidth that you need to consume. But then we come back to the previous point. The latency matters, but then how much throughput can you actually do, and does it actually meet the requirements of what you need to reach? But don't just believe the providers that you go with at the first glance. You need to do more research, and often that kind of gets forgotten. And to be honest, that research should also be done on your cloud providers because they are dealing with the same constraints as well. It could be that some of the availability zones or even specific zones within these data centers have some congestions to certain ISPs at certain times of the day. So you really need to do your homework if this is a crucial operation for your business. And then, final point, then you have all these multiple sites, right? There's usually a case where you have at the edge closest to the users serving the content, but you might have backends somewhere processing user authorization, maybe user payments, tokens, whatever. And then you need to figure out how do all my systems at these edges communicate with my backends.
Yeah.
Are my backends redundant? And can they communicate well? Are those connections? Are those physical connections? Or are those tunnels? Do they go back into VPCs, into cloud providers?
And because
yeah.
no, but because no, this is it's a great discussion because we sort of open a can of worms, and
Oh yeah, definitely.
there's just so many things that it's important to contemplate, and obviously none of them are. I don't want to say that one is particularly more important than the other, but the more that we start touching each of these facets, it starts affecting the latter and the former, and I think it's important to keep that into consideration, especially as you mentioned earlier, like there's this human operational load, not just the bare metal infrastructure, which, I mean, as technology evolves, these things, I think, become a little bit lighter.
Yeah.
In itself, they get commoditized. Exactly.
Being able to consume compute on demand is pretty much like standardized nowadays. But
correct.
But then managing the compute and installing the observability, that's where a lot of the workload and choices come in that you have to
correct.
Make. Yeah.
Maybe a side question about this, because we talk latency, and there's these human overloads, and then technology keeps getting better, and of course infrastructure keeps being a little bit more solid and I guess more permissive in the current growing market. The question, not necessarily the question, but whether compute moves closer to the users, or whether, let's say, like you mentioned earlier, maybe the cloud is too expensive, or we do a change to do something on-prem. What truly changes? Like oftentimes, we start tweaking these rather large decisions. And obviously, when we say it semantically, we say it commercially. Oh, we're going to do this, and it always sounds nice when you pitch it to the world, and but there's obviously a very tenacious work from engineering departments, from even market, but thereafter by marketing departments try to understand how to monetize this. What really changes, in this whole, I don't want to say ecosystem, but in the supply chain, because that's what it is, and we start restructuring this large volumes of hardware, software, and of course, intellectual power. So maybe you can share with us your vision and your your experience about what you're seeing.
I think I can definitely have some viewpoints on that, because we had especially during COVID, we had to undertake this exact scenario a few times, right? We were dealing with also systems which were at that point very centralized. So we were talking about those blast zones earlier, and there was then a need to distribute it close to the users. So if there was a problem with the internet somewhere, at least the impact was greatly reduced, and then the majority of the platforms would still remain stable. That's kind of the discussion that we had regarding where does my compute go, and how does it talk back to my more centralized back end, switch to more of the workflow logics compared to one which serve the users. But another thing is that going to the users generally is a performance improvement. Like going from a user from, of course, 200 milliseconds away to 10 is a massive, noticeable improvement also from the user point of view. Going from 10 milliseconds of latency to 2 milliseconds of latency, for a user, that's no longer noticeable. For him, it still is almost, it loads instant, it works. So from a user, the at one point, the perception of the user that in regards to the latency diminishes, but if you install all your observability and metrics, of course, your automated systems do measure the difference that the human no longer feels or can perceive. But tangible, it becomes a little bit less. Once you reach that ideal threshold of latency, optimizing even further might not be needed unless that single country has such a big population of users you want to go to a two-city solution just again for that blast zone reasons. Another thing is the more insights you have on your future expected workloads, the better you can plan your capacity and density. Like there's definitely countries where you want to be close to the users. Certain countries in Latin America instantly come to mind, but importing new equipment to these countries can be a very lengthy and difficult process. So for those countries where you know it's going to be difficult to scale up, the more predictions and analysis and think work you can do in what do I need 3 months from now and 6 months from now in these places is absolutely crucial to be able to make sure that your hardware will actually be there when you need it. And this is just regarding the compute. There might be compute might not always be the bottleneck. It might also be the ISPs that you're dealing with in a certain region. When looking at past projects, that's definitely the Middle East comes to mind, where capacity between the different ISPs is not always guaranteed. And if you want to increase it with those ISPs, we've seen in the past that can be a very, very lengthy process because of additional overland fee taxes, bureaucracy. So what in some parts in Europe might take a month to upgrade a private network connect with a certain ISP from 100 to 200 gig, in other parts of the world it might take a year. So there's different variances and variables regarding being able to expand your capacity depending on where you are. And in some of these cases you have to deal with it because there's no other options to be close to the users. In some other cases, depending on your workloads, you might be able to accept a little bit higher latency.
Correct.
And then put your stuff in the neighboring country to still be acceptable enough and have more flexibility in terms of going with your capacity up and down. But the more real time and the more interactivity there is in your product, like also if users can do actions back or, for example, talk back or stream back, some these interactive platforms, the more stringent the latency requirements are, right?
Of course.
And then you have to deal with it.
Of course, and I'm curious specifically about that because I mean this is all video workflows, and
yes,
something relatively constant is the encoding power, and obviously, through the chain things get compressed and uncompressed and transport, like this constant pipeline, let's call it.
Yeah,
and that that sort of not the pipeline, but that sort of transport. It fundamentally, does it change drastically, let's say, in the style in which it's done at certain places, or does it become more a strategic place, or you can say that a strategic density placement? Because things before, when the world was a little bit more linear, let's call it, it was certainly more simpler because things were in a bit of a panoptical way. You just sort of sent it forward and then people just consumed it and then we forgot it. You said the magic word before, that when you start doing this in an interactive way, which is how modern communications are happening, everything is sort of one to many, many to many to one, many to many, one to one, and everything gets juxtaposed through the network, and it's a circus that how can one, from the infrastructure perspective, make sense of that workflow and identify those pipelines?
One great thing you mentioned there is like the more interactivity there is, and if that interactivity also needs to get pushed back into that video stream, like for example, the player sets something back, it gets immediately featured back in the stream, stuff like that, then suddenly you can no longer suffice, even if you had before a product which was not very constrained by latency, and you could simply have maybe 1 or 2 encoding locations in the world, which then distributed the finished streams towards the edge nodes, which might have the users actually connected to. Now, when you have a lot of interactivity going on, then you also need your encoding your encoding clusters to be more distributed as well, and that's also quite an operational change to what it used to be, for example, 5 or 10 years ago.
Very different.
So, and that kind of ties back again, of course, to the original first point, that workloads do impact a lot also on your architecture. So depending on the workloads you want to serve, if you want to be a one-size-fits-all shop, then in my opinion, there's no way around that you need to have both the compute and your encoding capabilities, so also with the VPUs, as close to the users as possible. Because then you can, of course, serve any workload,
Of course,
on what it is, right? But but if you're more constrained in a team, you have a specific mission, a specific company, and specific workloads, then really look what are these, and then you can extrapolate it to then we need to be in these many locations.
Correct.
This many distribution clusters for the streams, this many encoding sites. It could also be like if there's interactivity, there could be a question. Okay, the majority of my users who are interactive and sending me stuff are located in these countries, so we need to be there. But content might then actually be consumed by another country across the world, where it might be popular to watch that kind of stuff at the same time. It could be even a sports match with interactive commentary that is being consumed by viewers somewhere else in the world. Or look at the Olympic Games, for example, of something that goes worldwide with lots of commentary and interactive possibilities nowadays in the streams.
That happens to be a little bit like, because we're talking that in the specific context, that's like sort of a workflow process.
Yeah.
But I think on this new world, on this approach, is more about what do you call that? Infrastructure, or maybe topology, logic, and understanding, what's really out there, and perhaps how it can be better leveraged. And obviously, incumbent technologies are technically able to do these things, but there's always this big, what do you call that? Commercial questions that have to be answered as well. In essence, anything is possible. Well, virtually anything is possible. But of course, if it costs an arm and a leg and it doesn't really move things forward,
what's
then
the balance?
What's the? Yes, we can do it, but it's not going to benefit anybody.
No.
Continue. Sorry. Yeah.
No, that's a really good point. Like we kind of tipped on it a little bit earlier, but how do you balance these latency and workload requirements versus the added costs and complexity that it might bring, right?
Correct.
We of course, like if it's purely your goal is user satisfaction, then optimizing that towards a latency point of view that the user can then no longer really notice it. If it becomes better or not is already probably good enough. So there's like you can continuously distribute all your workloads even further. But at one point it simply might not be needed anymore, or you're doing overkill on something that your workloads actually don't require. Yes, I mentioned, of course, you don't want a single cluster for a whole continent because of blast zones. There might be a bug in one of the routers causing problems. One of the ISPs might have an outage that you connect to that zone. But there's, of course, also a trade-off, like if you, instead of one big point of presence in Europe, you use 30, then you do have to observe and monitor 30 different domains for all the latency and those ISPs. So that does increase the stress and workload on your monitoring systems, on your live ops team. It needs proper playbooks for every single location, how to do escalation if something goes wrong. So that comes back again to the question, does my workload warrant that additional, complexity, stress? And sometimes it definitely does, but sometimes it does not, or only until a certain extent. Then you might go with 5 locations instead of 1, instead of 30.
Yeah, correct.
In that continent. I'm technical. I all the technical things in the company. And we as technicians,
to cover that.
We would always like to make it perfect. We like to build that Ferrari and make sure it works. But sometimes that also leads into getting into the trap of over-engineering.
Of course, correct. This you have to wait. How complex it's good enough before it starts not being beneficial for anyone in the party, right? Yeah, when we take the complexity of doing how do you balance well, not you, but how does one balance the benefit of lower latency against increased distribution and failure domains?
Yeah. The points that we covered just now are more like the risk we described, right? So if I would summarize that down to what would be my advice is, of course, avoid building a Ferrari if you don't actually need that Ferrari. So avoid trying to over-engineer, even though it might be technically satisfying to do so. But all right, look at
correct.
what does my client actually or my workload actually need, and then we build for that. The second thing is really sort out operationally with your monitoring teams and live of supporting people. How am I going to manage all my different domains and locations? And that by having that discussion, it will also become clear what's the limit or what's the overhead cost with adding another domain, another playbook. And the last part is figuring out as well when distributing something across many, many different locations is actually a net loss versus a net gain. It could be that 5 locations might be the optimal spread instead of 30. Or it could be that it can be just 2. Or it could be that your workload is not that latency sensitive at all, and you just want to distribute it to mitigate a single blast risk. Then maybe you can mitigate just maybe having 1 or 2 locations in a continent, and that would already be sufficient. So it's really looking at it strategically. What's my workloads? What are my capabilities? And yes, I also believe you should listen to the engineering feedback, but challenge them on does this meet the actual requirements, or are we over-engineering this at the same time?
Correct. Yeah. And it's a good segue, because now, there's a question, obviously, just to be not necessarily devil's advocate, but to, maybe understand when or is there a point, or where is the point where distribution itself becomes counterproductive?
I think from what we also learned in the past, when I look at our own past experiences, right? When we deployed and built out new locations in the past, for us, what always was most important, do our users will feel it being better by us being here? Will our clients feel a tangible benefit? And the benefit did not always have to be around latency. It was often latency driven, yes, but it could also be that by going towards that certain location, the internet ecosystem in that location was much more beneficial to get direct connections compared to the country we were serving them in from previously. It could be that from that other country we had to use middleman parties to reach those end users, whereas by going in that country, even though the latency might not differ much, we might be able to enable the direct connections with those ISPs. So you cut out the middleman, which is another party that you cut out that you don't have visibility over, that might add unreliability in your connectivity. So you get more control. Sometimes is that also a reason? There could be, well, no, there definitely is. In some of our cases, there could be legal requirements why you want to cover and be inside of certain regions. Having that clear is also very important, especially to legally firewall stuff regarding some sports licensing streams and so on, which can only be served towards certain countries or from certain countries towards certain users. Getting a clear picture of that could also really define, again, what's your workload going to be, but this is another thing that people might be overlooking on the workload aspect. Another thing that I would say, okay, let's say you've identified that you do need to distribute it pretty heavily. Don't try to do everything all at once.
That's a wise approach, and I think a very honorable one. A lot of people would try to maybe tell you, yes, do this and do it all the way, but no, this is a sensible thing to hear, Stefan. Good.
Just do it step by step. Start with adding one more location, verifying it all works, verifying that your teams know how to work with an additional location, verifying that the whole workflow from the encoding towards the end user consuming the streams and video actually works. And ideally, you by doing it incrementally, you learn from every time you expand a little bit.
Correct.
So you can apply the lessons that you learn towards the next location, and so on and so on. And that includes optimizing your design every time, being able to make use of improvements in hardware or encoding technologies with every new iteration. And also then being able to optimize your design for if something fails in one of those regions. And then have a self-healing distributed platform. That's kind of like the utopia that we all try to go for. That if I have a problem in a certain ISP in a certain region that I'm currently serving the content from, that I automatically detect this and redirect those specific users towards a location where they can optimally consume the content. That's of course the holy grail of having it distributed, but you only get there by doing step by step, like trying to do.
So,
yeah.
No, but this is great because then let's say for those of our audience that is listening, for those teams where designing latency sensitive systems for the first time, it's a challenge, or might obviously when you try to do something for the first time. At first, it always looks a lot bigger than maybe it is once you have done it the first time. For those listening out there, for a first run around, what would be your suggestion, or like a relatively simple approach for a rollout would look like? What would you say in a few points? Like, okay, consider this, that, so that people that may come back to us, after the session. We can direct them towards you and just say, look, this is how we can start, and just give them a little bit of a blueprint, maybe what do you call that, a podcast blueprint on how to approach it. That is simple, at least to ask questions and maybe take away a little bit of that monster feel of approaching the initial task.
Now, I think one thing that coming from me, people might find like, huh? If you're definitely starting greenfield, right? I would definitely, when creating your application and creating the links between where your stream comes in and you're processing the stream and then having clients watch it. When you're building this, I would definitely utilize, for example, cloud providers, where it's extremely easy to do your development there. Greenfield, start with a few VMs, get it all hooked up, even though it's not to scale, but at least you can start generating proof that it can work. You can also start experimenting, having that in multiple availability zones and multiple regions. And when you got a good feeling of a technology, and you have a good expectations of what your initial workloads are going to be, then of course you should make the step towards, before any big production traffic hits it, then of course you need to make the step to selecting the providers in the regions where your research shows that you need to be. And of course then it becomes a little bit more serious, yet still you're not at 30 providers right away yet, but then you're starting. Then you start optimizing at those few locations first with your first production traffic. Then when you have your first production traffic, it's also going to be the decision moment for your observability and monitoring. Do you actually measure your user satisfaction correctly? Other technical details? Does it report backly? Do you see problems with specific ISPs? You see reasons why you should expand to yet another country to maybe resolve those problems, and then you start getting into this incremental mode to go where your workloads and your latency constraints need you to go. Of course, it's a different scenario if you already have a very large production traffic volume, right? Then you're probably already with a big deployment somewhere. It might be very monolithic, one gigantic monolithic system. Then there are also still always two options. Again, you start doing a little greenfield project to build something ready for the future, or you start trying to disconnect tiny pieces from the monolithic system to see if you can duplicate this in a thin format into a new location. to see if you can get it work and get an additional distribution approach going, right? Because you already have existing tech. Yes, it might be old, but maybe you can still make the distribution part of it work. And if not, then you have to start fresh. And
Correct.
even when we look at our own internal systems, when I take a little self-blame there, like when we look at our own game orchestration platform, at one point we also decided that, okay, what we have now, it works for all the use cases in the past, but for the use cases in the future, which in this case was having the ability to go multi-cloud and seamless distribution, you need to start fresh because the old tech was from a time where a lot of even programming concepts weren't as developed as they are now. And even then, when I skip ahead a few years to today's world with all the advances in AI and how quickly you can bootstrap new applications and get to a POC, if I would have to choose right now, let's say I would be giving a big enterprise workload, maybe 10, 15 years old, and a mission task, okay, you go fix this, distribute it, and optimize the latency for our users. Yeah, I would definitely try to build applications from scratch. With today's advances, it is a lot easier to do so.
No, and obviously, especially it's always challenging.
Yeah.
I think it's exciting, but I think it's also something that requires a lot of collaboration. And for our audience who's listening, for those that are coming to NAB, we can have this discussion with our teams and just have a chat, really, because it's not really about just mentioning VPUs or mentioning infrastructure, i3D, etc. It's something that requires a lot of input from a lot of people at different stages of the video transport. So
I do think that one thing compared to, yes, users have always been critical. We always, also in the gaming as well, like pitchforks out whenever a game crashes or when the video streams is not working during an important event. Everyone is also instantly complaining. But the reason why it's even more pressing, I believe, in today's world is because there are so many other alternatives competing for your users' time. So if you have a hiccup, even if it might have been acceptable 10 years ago because they were just, okay, be annoyed, but continue watching. Now there might be so many other things, second screens, social media, competing for the user's time, that a small hiccup might mean that users are already gone.
Correct.
So in a way, I personally feel over the last few years that the demands towards the infrastructure, the video transporting, the whole chain have definitely become higher. It's more demanding, even though the latency, the geography didn't really change at times, but we cannot afford the level of interruptions anymore, which might have been acceptable in the past, and they are no longer acceptable now. Yeah.
Great. I guess what we can take from this session is that certainly number one, latency is not solved by a faster component. It's a much more complex challenge to fix, and it's certainly, like you just mentioned, is solved by architectural intent. As you said, there is more competition for people's attention, and we cannot lose them to a brief moment of distraction or signal failure. It seems that placement decisions affect density. It becomes this worldwide puzzle on how to maximize the video transport.
Yes, and also there's the legality aspect, which
correct.
With some workloads are really becoming a thing. There's always, of course, licensing requirements in the past with geofencing, but now in some of the countries that we are active in, the sovereignty requirements also start becoming play. They want to be able to point at where the data gets processed or encoded. So a couple of years ago, this was almost never mentioned in any of the presentations.
Because people associate latency like this archaic concept that every nanosecond it's what's important. I think that was well and dandy when it was just one signal coming from one side, glass to glass as they call it, and then it gets to here and then that's it. but there's the element that there's more interaction, there's more competition, not in just one screen, but maybe multiple screens, picture-in-picture methodologies of sharing information. And I think that what we're taking from this is that it's not just about the milliseconds and the fastness of delivering the video, etc., but more about the design of the entire system.
All the things around it and that impact and influence.
And I think that requires a lot of very smart disciplines to work together at different stages and deliver this, because it's nice, the FPGA technologies, but eventually it's okay. It's just the world changes. And no, it's great to have these insights from you, Stefan. We really appreciate it. This has been a very great grounded discussion. I think it's valuable for our audience, for people listening. Obviously, we try to just open the conversation. We have covered a lot of subjects here that maybe bring up more questions, and we simply invite people to come talk to us. We love having these crazy ideas, and then from there just kind of bringing them down and really delivering true innovative solutions into what's really happening in the market today. Thank you for joining, Stefan. I'm not sure if we'll see you at NAB, but I'm sure we'll see your team. So
the whole team is flying in, and if we don't see each other personally at NAB, then there's always, of course, IPC in September in the Netherlands.
Perfect.
Yes.
Thank you both, Leo, for channeling the real questions we hear across the market, and Stefan for sharing a perspective shaped by years of building and scaling distributed infrastructure. What's interesting about conversation like this is how consistent the concerns are across teams, not just performers, but predictability, placement, and operational control. For those heading into NAB, these are exactly the architectural discussions that matter, not headline metrics, but how video systems are actually structured and operated. Thanks for everyone listening, and we see you at the next Voices of Video.